Hello everyone, welcome back to the Game Engine Development Workshop series. Last time we started work on our dynamic rendering pipeline. We got this dynamic class set up. Right now each dynamic object stores its own render object, so its own vertex array, which means it requires its own draw call, which is very inefficient. So we also started work laying the foundation for a dynamic batching system, this indexed list. It's not done. There are some fundamental problems with it, with some of the big methods right now. So we'll fix those today and then get into the rest of our pipeline. A couple things before we start. When I was talking about like draw order and why that's important last time, I sort of gave an example in this main file here of having these two different objects, but on the video they were really dark, so you couldn't really see what I was talking about. So you can see here that my player, the one that's moving, is always drawn on top of the box, which is underneath, and that's because the box is being drawn first, and then, of course, if I flip those around, the player will always be drawn underneath the box. Like that. So I did that last time, but hopefully that's a bit more visible. Okay, so another thing that I realized is that that like example that I gave of the reason that we might need draw order for like a 2D top-down game where you want the player to you don't want the player's feet to collide with another character's head because that would just look kind of weird. It was really hard to show in diagrams. So what I have here is my personal game engine, and I just have a little example set up so we can see what I was talking about. So this is my guy right here, the player. And it would be really weird if I stopped right here, and I couldn't walk past this point because my feet are right at the level of his head, and within this perspective, that's pretty far away from him. So really, it would make more sense if I could walk down to about here, where the heads are much closer together. And then when I get to the other side of him, my player needs to be drawn on top of him because now the player is between the camera and this other character. And then I just have another one here facing the other direction. So you can see that if I were to stop out here, it's not very good. I don't know, it's fine, but we can do better. It looks a lot more natural if you stop about there. So that's what I was talking about with like those sort of hitboxes that don't take up the whole sprite, and also the reason that we need draw order. We need some system to automatically sort out our draw order, as you see here, where I'm behind him, I'm drawn behind him. When I'm in front of him, I'm drawn in front of him. So hopefully that'll help you visualize that a bit better. Okay, another thing I said, this was just like a quick comment I made, but I realized it could have been confusing. When I was initially writing this dynamic class, I said about each dynamic having their own render object that the overhead on the GPU is negligible. What I meant by that is the memory overhead, like the fact that each dynamic has a separate vertex array rather than what the system we're doing now, where there's like a single vertex array that stores all of our dynamic data. So what I was saying is that I don't think there's like a performance hit incurred by the additional like resources that you allocate through OpenGL to have each dynamic have their own vertex array, but there definitely is a performance hit. The space overhead on the GPU is nothing. The time overhead, because you have to draw each one independently, is very, very severe, and that's what we're fixing. So just to clear that up. Okay, so I have a bit of an agenda. We're going to go over the like structure of our whole index listing. I showed it last time, but I'll just sort of go over it again because it is kind of complicated. Then we'll finish our index list, and then we will actually do our dynamic batching system, which will have several classes that inherit from index list. And then finally, once we've got that set up, we'll actually get to handling draw order correctly by using something called a depth buffer in OpenGL. So let's pull that up. So this is like the high-level architecture of our system, where we have this list which stores all of our dynamics. Every single one is in this list. So it has a list of dynamics, and it has a single vertex array, and the vertex data for all of the dynamics is in that single array. it also has a list of these groups, and these groups are they're analogous to the sprite groups that we have for our static pipeline, because really their goal is to take a bunch of data and draw it all at once. That's basically what it is. It's a sprite group for dynamics, is essentially what that is. And the uint array here is a list of, or an array. I said array and list. List, I should call this a list and these fields arrays. So this uint array stores indices into this dynamic array in the list. And also each group has an index buffer, which has indices into the list's vertex array, because we only want one copy of the data for everything, but we can store it all in one place. There's no need to have each group also have its own vertex array. And then lastly, it stores a uint, which is its own index in the list's array of groups. So I don't know. That'll become more obvious as we start writing it out. And this is just sort of like the add procedure, the flow of data from place to place. We have a dynamic that we add to our list, which will put it into this array of dynamics here at index I. That index I is then sent down to a group where it is inserted into this array of uints. Remember, I is an index in this, and this array references that array. And then the index at which that other index is inserted into the group is the texture index of that dynamic. So that's what we need to set our the last element of our vertex data to, because that'll be passed to OpenGL, GLSL as the itext index there. And then, of course, each group also stores its own index buffer. So we have a dynamic, goes to the list. From there, it sort of splits off into the list's vertex array as well as one of the groups in the list, and then the group stores it in its own index buffer. Okay, so let's look at our indexed list class here and see what some of the problems are with it. So really it's our remove method that has problems. First of all, it doesn't really remove anything. It just sort of like says it's been removed to the internal implementation of this object because it marks this index as free, but the data is still there. And we can still access that data. Like as long as you have this index, even if you remove, in quotes, that element, you can still get it because it's not deleted. And this operator doesn't check for anything. It just gives you the element at that index. The bigger issue, however, is that we can, again, in quotes, remove the same object multiple times. So let's say I have two objects in my list. They're at indices 0 and 1, and I call remove on index 0. Then 0 will be added to our openings array. Then I call remove on index 0 again. 0 will once again be added to our openings array. So we now have 0 in our openings array twice. So when we come to add, next add, we get this the next index here. Which remember, if our openings array is not empty, it just gets the last element from that array and returns it. So the first time we add, it'll return 0. Okay, that's all good. But then the second time we add, it will also return 0. So the first add, whatever was part of that, will be overwritten. So that's a pretty big issue. And the way to solve this is to use a placeholder value. So something that when we remove from this, we set, we not only add the index we remove to our openings array, but we also set the element at that index to this like invalid value. Essentially, that's what the placeholder is. It's like a value that the user will specify. Sorry, the user will specify. They'll pass it into the constructor here as like a value that no element in the array could ever take on. It's like exclusively reserved for marking things as removed. Let's go ahead and do that. We'll store that as a member variable. And then in our constructor here, we'll go ahead and initialize our whole array to that placeholder value because nothing has been inserted yet, so technically every slot is empty. Okay. Now we'll need a bit of additional logic in our remove method. Our add method can stay the same. When we attempt to remove something, we'll just check if the element at that index, if it's not equal to the placeholder, so it actually exists and has not been removed yet, then we will set the element at that index equal to the placeholder, and then push back this index. So this prevents the removing the same thing multiple times, where if I remove 0 now, it'll say, okay, there's actually an object here, so this will pass. I'll set that object to the placeholder value and then add 0, but then the next time I try to remove 0, this will fail because we just set that to the placeholder, so the thing only gets added once. Okay, that's good enough for now. We are going to have to come back to this though. But let's go ahead and get started on our list. So this class right here, the list. So this will inherit from our index list. The type it'll store is dynamic pointers. And all we'll store for now is just the vertex array, which will, of course, be GL dynamic draw, because all of that data will be being updated every frame. I'm going to have a public constant static value here called max dynamics. I'll just set that to 1024. This is something that you can set however you want. It doesn't have to necessarily be a small value like 1024. I've just set that because I think it's reasonable and more than you'll ever need for most cases. But the reason we need this is that we have to allocate a set size for our vertex array. So we just have to just give it some arbitrary value essentially, and that's just the one I chose. Okay, so here we will override the add remove methods from our indexed list. So uint add, which returns the index, and remove, which takes in an index. And then we'll just have a draw method, which draws the whole list, and an update method, which we'll talk about later. So these are marked, I think I forgot to, function definition not found. Member function declared with override does not override base class member. Okay, so one of the problems here is that I didn't actually mark these add and removes as virtual. You need to do that if you're going to override them in a child class. But that's still not going to fix this one. And the reason is that the type that we've passed here is technically incorrect. So if we come back and look, we're taking in a type name t as our index list, which for our dynamic list is a dynamic pointer. And then our add method takes a const t reference. So that should be a const reference to a dynamic pointer, but we're just passing in a regular old dynamic pointer. And the syntax to get this to work is rather weird. It's I don't know, I don't like it. It also doesn't make any sense to pass a pointer by reference because it's just a number, it'll just be copied. There's no reason not to copy it. So what we'll actually do is add a couple more type names here just for convenience, just because it'll make inheriting from this class a bit more user-friendly. Have a type name return, and we'll give these some sensible default values, just so that The user doesn't have to override them if they don't want, but they can. So then, well, actually, so we have 3 new types. We have return, which will be like the type returned by add, essentially the like handle into this list, the index object, whatever that is. Have add, which will be the one, the type you pass to add, and then remove, which will be the type you pass to remove. And that's all we'll do with that for now. Then we can come back here and set some of these. So our return is still going to be uint. Our add, though, will just be dynamic, and we can make that dynamic a const pointer. We're not going to change the pointer itself. And then remove, we'll also do dynamic const instead of a uint. So that one will require a bit more work because it's like different from the base functionality. Okay, there we go. Now we can override everything without those annoying issues. Go ahead and create an implementation file here. I'll just copy all this. Okay, so we have our constructor and our destructor here. The constructor, we don't actually do anything with. We just have to instantiate our parent. I'll just copy this long type name. So a cool thing you can do in C++, when you have really long like type names like this that you don't want to type out all the time, what you'll often do, like the standard library does this a lot, is you'll like type def that as like parent. So then in here, I can just do like dynamic list parent and then pass in all the things. I don't like doing that. I think it's confusing. But if you are doing lots of stuff with like super templatized types all over the place, then I definitely see the value. But we're not. This is just like a one-time copy paste thing. So into this, we need to pass the count, so the max size of our array, which for us will just be max dynamics, and then the placeholder value, which in this case is easy because we're storing dynamic pointers, so the placeholder is just going to be null pointer. And then we will default our vertex array to null pointer. Okay, so in our destructor here, we have an important architectural point here, which is that the dynamic list owns all of the dynamics that it contains. So this imlist is the list here in the index list, so the list of dynamic pointers. So when you add a thing to this, when you add a dynamic to a dynamic list, you like basically you give this dynamic list complete control and ownership of that dynamic object. And that means, most importantly, that when the lifetime of the dynamic list itself ends, all of the lifetimes of its contained dynamics will also end, and so they need to be deleted. And so if you try to delete something that's already been deleted, it's going to throw an error. So we'll have to keep that in mind. Okay, we have add. It's pretty simple. It's actually not that simple, but for now it's simple. I'll just give an outline of it. So we'll set imlist at next index equal to the dynamic that we're taking in. Then we will find a group, so that's this other type here. Find a group for D and add it to that group. And then, of course, we have to return the index, just because that's what this method does. So that's add, remove. We will do imList at, I didn't actually name that. At d.index equal to null pointer. So this is just part of like the base remove functionality, just setting that equal to the placeholder value, which in our case is null pointer. And another thing to note here is that the dynamic, because we're passing in a dynamic to this remove method, which we don't have to, I've just done that just because I think it makes the like resulting code a bit cleaner. Each dynamic has to store its own index. So that's why I return it here. So we'll return the index and set d index equal to it. Then of course we will add d.index to our openings list. And then when you remove something, we might want to get rid of all of its vertex data in the array. And our draw functions, or our draw and update functions, I'll also just outline for now. The reason I'm outlining all of these instead of just writing them right now is because our list and group class are very interconnected. And so I can't actually write most of this without having defined the group class first. So I'm just outlining it here. We'll do the same thing in group and then come back and write all of it. But basically our draw will just loop through all of our groups and draw each one. Then our update method, this is going to be used, it takes in an index here, and it's going to be used to update the vertex data in our vertex array here for a given dynamic. So we get new vertex data from imlist.i, and then we upload it to the right place in our VA. Okay. So looking at the add and remove methods, we already have an index list, and the stuff we want to do in our dynamic list overrides of those. They're pretty similar. We have setting, for add, we want to actually add it to the list at the next index, and then return that. For remove, we want to set it to the placeholder value and add that index to the openings list. But remember, when we override a method, the actual base methods are no longer called. So what I'm going to do is like take this common functionality that we want here, and just move it into some separate methods. And these will not be virtual. So this will be called add base and remove base. Add base will just return a uint. And I think we leave the rest of it the same. Then remove base will take in a uint. And this is important because at a certain point, you have to be using uints. You have to be using indices into the actual array, even though in our overrides here, we're not taking those in. We're taking in dynamic pointers and everything. But we do eventually need to end up at returning a uint and removing a uint. And then I'll just sort of re-add these, but I will make them pure virtual. Have add and remove. Okay. Now we will start on our group class. I'll call it draw group. You could also call it dynamic group. namespace engine, and we will forward declare our dynamic list class, because we need to use functionality from both, like within each other. But obviously you can't have two files that include each other, so. And this one will be a little bit simpler in terms of the operations. It's just all going to be on straight up uints. Okay, so we have, as part of our group, we have an array of uints, an index buffer, and then a uint itself. So uint index be the index of this draw group within the dynamic list that it is part of. We'll have an index buffer, and this will actually be dynamic draw, because as we add and remove dynamics, like the indices for a given dynamic will not change, but as we add and remove them, our index data will need to change, because the index data is ultimately what controls what is actually drawn from the vertex array. So if we remove a dynamic from our dynamic list, then we need to say, hey, don't draw these indices anymore, because like that's just, there's no reason to. It's a waste of time. And then we'll have a mutable thing here. This is just like, I've marked it as mutable because I think it, I don't know, it like signifies that it's not part of the, like, it's not like a feature of the class, really. It's not, it doesn't like provide any functionality on its own. It's just there, as we'll see, to make it a bit faster. Okay, so let's create an implementation file here. We will add the list of uints in a minute. We realize that it's not actually going to be a list of uints. Okay, so we're going to have some similar operations. We're going to have an add. Again, in this class, we're just dealing with all uints. We're going to have a remove. And then we will have a draw. And then a simple constructor that just takes in the index to be assigned to mindex and nothing else. And then we'll just delete the ones we don't need, the ones we don't want. We will have a simple destructor here just to delete our index buffer. Okay, other than that, just copy it all in here. And we'll do the same sort of thing that we did with our dynamic list of just outlining what we're actually going to do. So the count for our draw group, the max size of the actual underlying list is going to be get max texture units. Because a draw group, again, its purpose is just to batch multiple dynamic draw calls together. And we don't have a system for drawing things with two separate sprites, like using the same sprite, or two separate textures using the same texture. So we're just going to store each dynamic that has a unique texture individually. And then the invalid value, or the placeholder for this, will be max dynamics. Because remember, what this index list stores is a list of uints into an array of uints into our list's array of dynamics. And our list can have up to, like, the maximum index within our dynamic lists array is max dynamics -1, because that's going to be the length of that's the length of the actual list. And so that's the invalid value. Okay, then we'll just copy this index that we received. And then just create our sprite buffer. That doesn't actually work. That should not be done. It should be mSpriteBuffer.reserve. I don't remember what the difference is between. There's like a standard vector constructor that takes in a size, and I don't think it like actually reserves that amount of size. I don't know. It does something weird. But reserve will just mean that this amount of storage is already allocated, so we'll never have to allocate more. And then within this, we'll just set everything to null pointer. Okay, so for our outlines here, our add method, we'll get some index, which is equal to add base. This method we just sort of extrapolated out here in our index list. We will create index data for given dynamic. We will upload that index data into our index buffer, and then we will return index, this one that we got up here. In our remove, we're just going to call remove base, so actually remove it, and then remove relevant indices from our index buffer, because remember, when we remove something, we no longer want that thing to be drawn, obviously, so we need to remove the index data that's actually drawing it. In our draw method here, we will go through each element in our list. If the element exists, because remember, this index list thing, like the list can have holes. When you remove something, nothing is shifted. It's just like set to an invalid value and then marked as empty, but you can still get to it and operate on it even if it is an invalid value. So if the element exists, so it's not equal to mPlaceholder, we need to update it and add its current sprite to our vector. Then we will draw everything using the vertex array of the list we're taking in, our index buffer, and our sprite buffer. Okay. So I think I'll try and talk a bit more about why like everything is laid out in this weird way, and we can sort of see that a bit better now that we have everything outlined. There are two like important dependencies that we can see now. Each dynamic will store its index within the dynamic list that it's a part of. When we call dynamic list.add and we pass the dynamic, we are storing the index that's returned to our dynamic so that it can keep track of it. And the reason we need this is if we don't store this, then removing becomes extremely expensive, because when we remove something, all we're essentially going to be doing is like deleting a dynamic, you know? and we don't have any other information. We only have the dynamic that we want to delete. And so if we don't know anything about where that dynamic is in our actual structure here, we have to search for it. And that's simply order in. This is not sorted in any way. There's no like trick to finding it. It would just be a brute force search, which is slow. We don't want to do that. So instead, we just have this very simple like workaround where we store the actual index of our dynamic, and then we can go right to the place we need to delete it and delete it. And it's super fast. But our dynamics vertex data here, the index, the fifth element of each vertex that we're setting, depends on its index within a draw group. Remember this green one, J. So we also need to store that. We need to store a uint for its position in the array in the list, but then also for its position within the group. And again, that just sort of same thing I was saying before. We need constant time removal. But something we didn't that we didn't plan for yet is that our draw group indices must also remain constant. Because if we remove something from this draw group, we don't then want to have to go through every other element in the draw group and update their indices so that this I value gets set correctly, because that's slow. So this draw group, the indices need to remain constant, much like an indexed list. So let's write that now. Well, I think this is confusing because I haven't actually written it yet. But what we need here, essentially what I'm talking about is our list of stuff here, like M dynamic indices or whatever, which is this array in our diagram here, the thing that actually stores the indices that come from the list's dynamic array. These need to remain in the same order. Otherwise, we have to go through everything and update it. And we already have a class to do that. It's indexed list. So we need like a third class here that will be stored within each draw group to keep its internal indices in order as well. So let's create that now. Be called a draw group list. It's going to be an indexed list. Type is going to be draw group pointer. And this is going to be super simple. We don't need to store any other data. Just going to be a basic indexed list. Again, this is just super simple. All we need is the base functionality. Like that. And then we'll need a very short implementation file just for the destructor here. Because it needs to delete all of its draw groups. So we need to do this here because we can't include drawGroup in here because we need to include drawGroup list in drawGroup. Same problem we had between these two. So we just define it. But then if we've only defined it here and then we call the destructor doesn't exist here. So it's just going to do nothing. So we actually have to include it over here in a C++ file and then delete it, and everything will work properly. Okay. So now we can come back to our drawGroup class. I'll go ahead and mark this as like a friend class of dynamic list, because all three of these classes, you know, they work together pretty closely, and so it'll be a lot easier to just let this have like access to all of these private variables than to use getters and setters for everything, just unnecessary. So we'll have a draw group list. We'll include draw group list. Handle called imindex. So let's go ahead and define handle. That's going to be an index list. All a handle is it's sort of what I was talking about earlier. You can type def something. But all we are going to type def is whatever's returned by the add method. So when you add something to a list, the value that's returned is like the value that you'll use to perform further modifications on that object. So it's called a handle. But you could also call this index or whatever. Okay. Get rid of that uint one. And I think that's all we have to do here. Next, we will come into our dynamic list once again. And actually, oh wait, I did forget one thing. And this is why I marked dynamic list as a friend class. You're just gonna have to see it. Like, I can't really explain it, but we're no longer going to take in an index for our draw group, even though we need one. We'll just set it to 0 by default. And then now that dynamic list has access to all of these private fields, that can just set the index directly when it knows what it should be. So we'll see that in a minute here. So within our dynamic list class, I'm going to go ahead and create a custom structure here. Dynamic list handle, which has a uint list group and texture. So list will be the index of the dynamic added within this actual, like the actual underlying list of the dynamic list. Group will be the index of the draw group that the dynamic is now contained within, and then texture will be the texture index of that dynamic, which is the index within the draw group that it is stored. That's confusing, but remember, we need to store multiple indices so that we have order 1 access time for any dynamic. We need to know exactly where it is. So we'll set that as our return like template type there. And of course we have to return that as our add method. Okay, and now we will come back into dynamic finally and just add like modify this constructor just to take in a dynamic list reference. So when we create a dynamic, we supply it with a list, and it will automatically be added to that list. And then now we need to store our handle. And this is why I didn't call this type like index or something, because that could get confusing, even though I've just called it index right there. Because it's not really an index. It's like an object containing multiple indices. So this will be the index at which our dynamic has been added to this dynamic list that we take in. And then we will need to force edit this. And we will just set mindex equal to list.add this. We have a list, and dynamic lists add method takes in a dynamic pointer, so we just give it this. And another thing we can do in our dynamic at this point is just delete our render object. We will no longer need that. So I don't even think we'll need a destructor. Get rid of all this. Comment that out for now. And delete that. Okay. Now within our dynamic update method here, after we've updated our vertex data, we should call list.update. This will also need to take in a dynamic list. List.update on mindex.list. Because remember, our dynamic list update method will get the new vertex data from the given index and upload it into the actual vertex array. And this is essentially what was happening before. When we were storing our own vertex array, we were just updating that as part of the update vertices method. But now that we don't have our own vertex array anymore, we just have to add this other line to do it to wherever this is stored. Move that over here. Last thing we will do is this. Now are no longer just drawing one thing per draw call. We're doing up to 32 or 16, whatever your system supports. So this should not be hard-coded to 0. This should be mindex.texture, the texture index of this dynamic. Okay. This is a lot of like moving around, and like I don't think there's a better way to do this. I mean, I obviously thought about just like going through it linearly and just doing like one of these at a time, so I wouldn't have to flip back and forth as much, but I don't think I would do as good of a job explaining if I was teaching it that way. So I don't know. Hopefully this makes sense. Okay, so now we'll start actually implementing some of these. So we need a UN index equals add base on the index we're taking in. Then we need to actually generate index data. Just store that in a local array called count. And then set indices at I equal to dynamic times vertices per quad plus S index offsets at I. Okay, so this statement. So S index offsets is just this thing we have in our core file, which is just the 012023. So that should make sense. That's like the base pattern that we need. But the dynamic we're taking in here, it's a uint. It's the index of a dynamic. And that index, like whatever index a dynamic is inserted into within our dynamic list, will control where its vertex data is within the actual vertex array. And each dynamic is just a quad, so it has 4 vertices. And so this basically says if we're inserting dynamic at index 0, that's just going to be 0 times everything. So we do it. Its indices will be 0, 1, 2, 0, 2, 3 because it's the first like set of vertices within our vertex array. But then for the first, this dynamic index, or sorry, I guess technically the second dynamic, the one at index 1, will be 1 times vertices per quad plus this. So that would be 4 plus 0, 1, 2, 0, 2, 3. So 4, 5, 6 4, 6, 7. So this just like is a clean way of calculating the correct indices that we need. And then the next step, once we have those, is to actually put them into our buffer at the right place. So the count we have is indices per quad. That's easy, just 6. Data is indices. Now the offset is going to be our local index, the local index of this dynamic, the one within our draw group here. So not the one we're taking in, but the one we got as a result of adding this, times the number of indices per quad. So for our first dynamic, this would just be 0, because index would be 0. But for our second dynamic, the one at index 1, this will be the offset this will start at. It's always inserting 6 elements, but the offset it'll start at is 1 times 6. So the first 6 indices that were inserted, the ones for the first dynamic, will be untouched. And then the last step is just to return our index. Okay. Now we have remove, which is a bit simpler. Just going to remove base on the index we're given. And now we have to remove the index data for this dynamic. But there's not really a way to remove data from an index buffer, because remember, it's constantly sized unless we want to reallocate it, which we're not. There's no reason to do that. But what we can do is just using that same sort of equation that we used in add, this index times count to determine the offset to start at, because this index is we get from adding base, from actually adding it to this group, and then we return it. And so then whichever value is returned here will be the one that's passed in to remove. So this index and this I will be equivalent for any given dynamic. So we just create an array of the correct size, storing all zeros. So we're just basically drawing a quad using the same index 6 times, which obviously will have an area of 0, so nothing will show up on the screen. So we're not really removing it from the index buffer, we're just making it so that that index buffer doesn't end up drawing anything. And our draw method here, also quite simple. Just have to check whether or not the current element exists. So maybe it's not that simple. It's a little confusing. I'll talk about it. Once we get everything, we need a new method called draw dynamics. Okay, so let's go through this loop. So we're going through from 0 up to imp count. So starting at the start, going to the maximum size of our array. Already, that's kind of bad. Like, that's unnecessary because we might have 1 or 2 elements. So there's no need to loop through the whole thing. And that's why we have this get last method, which returns just the last index that we, or I guess the next index to add to. So going up to less than this index will give us from 0 up to the last index that we added at. And this way we don't have to waste time looping through the whole array if we only have, a small number of elements. But just because we're going through that doesn't mean that each element at all of these indices is guaranteed to exist, because we could have removed it, in which case it's set to the placeholder, which in this case is null pointer, so dereferencing a null pointer obviously is an issue. Can't do that. So I'm going to add this other method here, is valid, to our index, what's it called? Indexed list. Just going to be a private method that takes in an index and says whether or not there is like actually an element there. So first of all, I has to be less than the maximum size of our array. And element in our array at that index is not equal to im placeholder. And this also works if it hasn't been removed yet, if it just hasn't been assigned. Because remember, in our constructor here, we set the whole everything in the list we set to this placeholder value. So this will return. This will be valid only if something has actually been added to the given index and is still there. Okay. Now we have this rather confusing sort of double array operation here. Oh, I forgot to do that. So I set dynamic list as a friend class of drawGroup, but I didn't set drawGroup as a friend class of dynamic list. There we go. Now I can just access that private member. And this probably I need to include dynamic. Okay, so we go through up to the last element that we've added. We start with a sprite pointer of null pointer. I forgot the most important step here. So we start with a sprite pointer of null pointer, which we want if the current index is not valid. Obviously, there's nothing there, so the sprite is also non-existent. But if it is valid, we get the dynamic at that index, and this expression is weird. So this for loop loops through this drawGroup's im list, because remember, drawGroup is also an indexed list. And what the drawGroup's im list stores is indices into a dynamic list's im list. This. The drawGroup's im list, so like this is im list. And this is also im list. So we have an index into this list, which in turn is an index into this list. So that's the reason for this weird thing, is like we have an index into our list. Putting that index into our list gives us an index into this other list, and then we actually get the element at that index in the other list. So that gives us a dynamic pointer. And then we update that. So move it, everything. And then we get the current sprite of it. And finally, we set our sprite buffer at the current index equal to whatever sprite pointer we ended up with. And then once we're done getting all of the sprite pointers, we draw everything. So we're going to need a new method here in our renderer class. This is going to be similar to the ones we have, kind of, except we're taking in our index buffer and our vertex array separately instead of as a package as a render object, because now we have our dynamic list stores the vertex array part, and each drawGroup stores its own index buffer. So we take in the vertex array, index buffer, and a vector of sprite pointers. And then I'll have this method called drawBase, because it turns out even though this method is different from our current draw methods in that it takes different parameters, the functionality is essentially the same. and we can get rid of this last draw method that we added last time just to draw our single dynamic at a time, which obviously now we no longer need. Oh, I just deleted. What did I do? Oh no, that was right. Okay, so now we just have our draw dynamics method and our regular draw method, which is used for our sprite groups. Okay, so I'll come down here. I have a gonna do some more C++ magic. It'll take in a standard vector of sprite pointers because we need that regardless, and then also whatever else we give it. And I think I can just copy and paste a lot of this functionality here. Let's see. So we'll go through the whole list of sprites. I guess I'll leave that. If the current sprite exists, then we'll update it, add its values to the texture buffer. Otherwise, we set the value in the texture buffer to a null pointer. And then we update this with sprites.size and texture frame. So yeah, all of this stays the same, except our imRenderer.draw call. This is going to have to change. So we'll need we'll just expand whatever this args thing is, whatever type this is. I think I did some syntax wrong here. I did. That. Okay. So back up here, I'll finish this off, then we'll go to our graphics renderer. So we'll draw base with sprites, our render object, our texture buffer, the number of sprites, and then imShader.statics. Because now that we have dynamics and like map data, we are actually going to add a second shader here to our shaders struct. We'll get to that later though. Okay, so now we need graphics render methods to match these definitions. So at this point, I'm just going to get rid of these top two. These are like really old. We don't need them anymore at all. But we do need a new one that takes in the vertex array and index buffer separately. And then we have our list of textures, the number of textures in our list, and our shader. And then similarly, we will have a draw base method in here. Which will be private. This takes in a bunch of stuff. Okay, so we'll do basically what we're doing here. Except without object upbind. So we're binding our shader. We'll also just add a check to if textures at I. Just make sure it exists before we bind it, because now that we are drawing things in our draw group here, there is a potential for some of these indices to be null pointer. So we need to check that. So if textures at I, then we bind it, and then we draw everything like that with the index count that we've taken in. Okay, so let's see how this is actually used. Obviously we have this one call to draw base, but now we have another. Okay, so we have it. Let's look at the similarities between these. We have textures array, obviously, count, texture count, index count, shader, and then some other args. So we have, in this one, we have a vertex array and an index buffer, which both need to be bound. And in this one, we just have a render object, which needs to be bound. And all three of these types have a .bind method. So what we can do here is something very strange syntax. I can't remember what it's called, but all this does is it goes through, because remember this type args is just like a compiler generated type that stores whatever else you put in it. So in this case it stores a vertex array and an index buffer, but in this case it's only a render object. So this just like expands this parameter pack and does this operation on each element within it. So in this case that will do bind our vertex array, then bind our index buffer, and in this case it'll just bind our render object, which in turn of course does the same thing. But this is a clean way to write that, just so that we can have these be like single method calls. Okay, at this point I'm going to compile because I'm pretty sure I've messed at least something up. Yeah, count should be texture count. Messed a bunch of stuff up in here. This would be im shaders, and of course we also have to add our dynamics shader. So let's do that. That will be simple. We'll just take in another file path to our constructor here. So we'll have one for statics and another one for dynamics. Have another shader as well. And we'll just do everything to both shaders. We need to update that constructor. Take in both of our file paths. Like that. And then that's now going to be messed up in our main file here. For now, we'll just use the same for both, but we will be changing that shortly. And we have also updated our dynamic constructor to require a dynamic list. So we'll create that. Include it first. Dynamic list. Then pass it into our dynamic constructors here. And then the update method also requires our list. Let's see what else we've got. Indexed list. I messed something up. I spelled placeholder wrong. Okay, that seems to have been most of it. Let's rebuild. Oh wow, I spelled this wrong all over the place, huh? Guess it probably auto-corrected me. Okay. Wow. And now, what do we have? Indexed list. Oh, I just forgot to change the, when we changed the, like, return type of our add method. I forgot to change that on the in the constructor here, because this is a compiler generated type, so it will be different from this compiler generated type. So we need to make sure those arguments are the same. It's probably the same error. Okay, that looks like all of it. Close. This is just some. I'm not going to worry about that right now, because we have not actually defined stuff. Okay. So that was a lot of work, but basically the point we're at now is we have everything set up in our renderer, both of our renderer classes. We just sort of cleaned those up, got rid of all the old stuff, and condensed a lot of the common functionality down into these draw base methods, which are very nice. So now in our draw group, we can just call render.drawDynamics, and it'll sort everything out for us. Okay, so that's our draw groups done. We still have all of this left to do in our dynamic list, so let's get started on that. This one is a bit more complicated, the add method especially, and I'll talk about that once I'm done writing it here. But basically, what we're doing is actually searching for a draw group to put this in, which is kind of bad. So for each group, we will check if it exists. And if it's not full, we will add to this group. If we didn't find any lists, any existing lists, we need to create a new one. I'm missing a bunch of includes, I think. And then we will just return, we have to return this this thing, dynamic list handle, which has a list index, a group index, and a texture index. Okay. So that was a lot of stuff. Let's first of all define this actual draw groups array, which will be, well, it won't be an array. We have now this new class draw group list. Just like that. And this is a super simple class. It just takes in a uint count. So that's going to be, what that represents is the number of draw groups that we want our dynamic list to contain, the maximum number. And that will be the total number of, the maximum number of dynamics that we can have divided by the number of dynamics that fit in each group, which is just gfx get max texture units. So that'll be the max number of groups we actually need. This add base is yelling at me. I'm not sure why. Oh, I didn't actually. No wonder. Gotta add that qualifier on there. Okay. So this is just simple. We're just inserting this at like the next available slot and getting the index. And then here we are going through all of our existing draw groups and trying to find one that has room, that is not full. So it has room for another dynamic. If we do find one, then we set this found flag to true, which will exit our loop. We set the draw group index to the current index, and we add this dynamic to that draw group and store that as the texture index. Because drawgroup.add returns a uint, it takes in a uint and returns a uint. So just store that in texture index. And found is true, so this won't run. But if found is false, if we don't find an existing draw group that has a spot, then we have to create a new one. And this is similar to what we're doing in Chunk, where we go through our existing sprite groups. If any of them have space, we add to it. Otherwise, we create a new sprite group. So we have to create a new draw group here. And then just same as we did here, basically. We set the texture index equal to group.add. We set the groups index. Remember that each draw group stores an index into the array of draw groups that the dynamic list contains. So we sort of bind that to mdrawgroups.add, the list containing the new draw group. And then our draw group index will just be the exact same thing. So we could write this as like that, but I think that's a bit confusing. And then at the end, we just return everything. So how could this be better? Well, this is potentially slow. If you have a lot of stuff, a lot of dynamics already, you probably don't you don't want to be searching through all of your draw groups in your draw group list whenever you add a new one. You will still have to do this, like creating new ones from time to time. There's just no way around that, because eventually you'll run out of space in the existing ones. But this could definitely be better. I haven't actually included that here because I think it would be trivial. Hopefully you would also leave it to be trivial, because all we need here is literally the same functionality that we already have in our indexed list. We just need a vector of open spots, where in this case the openings are draw groups that are not full, and then we just get the first open index, like the first draw group, the first open draw group, and if that doesn't exist, then we create a new one. So that would just be like a simple cache thing. But this isn't terrible. Again, it will be like slower for stuff that for when you're adding stuff when you already have a lot of stuff, a lot of dynamics. But even then, like this isn't going to be running every frame. Like spawning and despawning dynamics is not going to be that like frequent of an operation, so it's not too terrible. But again, like really, you should be sort of caching which indices, which draw groups have room. And I just didn't want to do that because it's literally what we've already written, so that would have just been a waste of time. But just pointing out there that this is like technically bad. You should fix this. Okay, so that's our add. It's a little bit complicated just because we have the search, but otherwise pretty boilerplate. And as I said, like you've already seen the exact same thing in our chunk. So now let's do remove. We will get the indices of the dynamic we take in. We could just take in those indices directly. I think it's cleaner to just pass in this because I have like a perspective of how this will actually be used. So that's what I've decided to do here. In order to actually access these, of course, we now have to mark dynamic list as a friend class of dynamic, which I don't know. Like at this point, like it's fine for these classes. I guess it's really just these two to like be friends of each other because they're so closely related. Dynamic, like once you start like spreading this friend class, like the roots get everywhere out into the rest of your program, you probably should stop yourself. This isn't too bad. It's just like one other file, but anything past this, like it becomes a trap. You should use regular object-oriented stuff. It's just so much easier to keep track of. But we'll just get the indices there, and then we will remove base. So remove base takes a uint, And our indices is one of these. Contains 3 units: list, group, and texture. So first, we're going to remove the actual dynamic from our list of dynamic pointers. And the index of that, as you can see here, is returned as index, the index that is returned as a result of add base, so actually adding the dynamic to our list of dynamics. So we just remove that same index. But then we also need to remove it from the correct draw group. So we'll get the draw group at indices.group, and then call group.remove on indices.texture, because remember, texture index, in addition to being what is actually set in our vertex data here, is the index of this dynamic within the draw group itself. So that's what we pass to remove. And then at this point, say, just very simply, we have a dynamic list that only contains one dynamic. And so it has a single dynamic group, or a single draw group, sorry. And we've now removed that single dynamic from our list and also from our draw group. So our draw group is now empty. So we should delete it. There's no reason to just leave it hanging around. Now, if you did have like a simple caching system like I was talking about for your add method, it might be best not to do this, because this is like deallocating dynamic memory, which then incurs another allocation when you need to add the next thing. But in our simple system, we'll just go ahead and actually delete this draw group from our draw group list. And the index that we want to delete there is group at index, which, if you remember, is set up here as a result of adding this draw group to this draw group list. So this is a lot of indices all over the place, and it's probably very confusing. But again, like, we need this thing to be fast. We really want to do as little searching as possible. We want to do no searching. Even the small amount that we do have when we add is not great. And it's also like interdependent that I can't really teach it in a straightforward fashion. So our draw is just very simple. We just go through all of our draw groups and draw each one. And then our update will be used to, this is called from our, where is it, dynamic.update. This will actually get the newest vertex data from the given dynamic. But if we give a bad index somehow, we should report that. Otherwise, we will get our vertex array dot get buffer dot update. The count is going to be the number of floats per dynamic. The data is going to be imlist at I dot get vertices, which we'll have to add. And then the offset will be I times count, because this is the index of the dynamic within our list, and each dynamic has s floats per dynamic, like floats. It takes up that much space in our vertex array. So this will give us the start of our given dynamics vertex data. So now we just need a simple getter for our get vertices. Just like that. Probably can't be const. Yeah. There we go. And actually, we should probably make that const. There's no reason to be able to change that. Okay. And this get vertices method will always get you the most updated version, because update vertices is called right before this method. So we move our thing, update our vertex data to reflect that thing, and then send our vertex data to the GPU. Okay. So another thing, another just small like performance improvement I'll mention here that you might be able to make is like all these for loops where we're going through I equals 0 to get last. Um, it might be faster. I'm not sure. It might be faster to like store another vector that's sort of the opposite of M openings, that stores all of the indices at which something actually exists, and then just go through that list of indices so that you don't waste any time looping over um, like non-existent objects. In our case, like that, I think that would only really have a performance impact if you had tons and tons of stuff. But I don't know, just something I thought I'd mention. Okay, so we have like all of our stuff in place. It's all like actually written out now, except actually drawing it. We have space for our vertex array and our index buffers, but we're not actually making them yet. But we will need some new constructors for these, because currently, let's see what our constructor takes. Oh, let's just go here. So it takes a count, is good, a list of vertices, and this list controlling how the vertex data is described. But we don't actually have a vertices list at this point. Like in our dynamic list here, when we're creating our vertex array, we don't have any data yet. We haven't added any dynamics, so we have nothing to put in the array. So we'll just create another constructor that takes an account, which we still need, and the list, the description. Actually, I probably could have just copied all this. It's mostly the same. But then here, we'll have a base method, private void init. And this is going to take in a standard initializer list, and basically just do what this constructor does. So create the actual array, bind everything together, and then describe everything. The difference is that so we're going to call this from both of our. The difference is that in this constructor, we're just initializing our buffer, our vertex buffer, with a count, no data. But in this one, we do actually have data to give it, so we give it the count and the data. Okay. And we'll need to do a similar thing for our index buffer, because we are also creating those within our draw group, and they should be 0 initialized because we have nothing to put in them. So we'll have very similar index buffer, just takes into account. I'll just copy this. Give the count to our parent, and then we'll similarly have a private void init, which will just take in a Boolean controlling whether or not to set this all to 0. Because our index buffer doesn't take in any actual data. Like it doesn't take in any data that's uploaded to the GPU. All the data that's uploaded to the GPU is automatically generated using this for loop, which that goes through and like does everything for you based on the vertex array you've given. Which is good. Like that's fine. We don't want to change that, but we don't. When we create a draw group and we have nothing in it, all of our indices should be initialized to 0. Because again, we don't want to draw anything, and we don't even have anything to draw. So we'll just take in a flag, and we'll set it to true for this one. So give me all zeros, and for this one, we'll set it to false, so it'll actually generate all this. And then here, just have a simple ternary. If we've set 0, we'll just set every element to 0. Otherwise, we'll set it to that default statement. Okay, now we can actually create these. A vertex array will be a new GFX vertex array. It is dynamic. And it just takes in count, so S max dynamics times S floats per dynamic, because it needs the number of total floats. And then the description, which will just be 221. Okay, and our draw group, same thing. This will be a new GFX index buffer. Get max texture units and indices per quad. Okay, so we do have kind of I don't know. I think I'll just go ahead and finish this. I'm not actually sure what time I started, so I don't know how long this video is, but it's probably only like 15 minutes left, maybe 20, and I don't want to split that between now and next time. So we'll just go ahead and power through it. Sorry if it ends up being a longer video. But at this point, I'll go ahead and compile just to make sure I didn't make any dumb mistakes, which I certainly did. Oh, actually, need to pass all of this down. So this stuff just controls how the how all of this is generated. And actually, we don't need it in this constructor because this constructor isn't going to use that expression. Because remember, 0 is set to true, so it's always just going to do this one. But they do need to still be they can't all be 0, I don't think, because we're doing division. So I'll just set them all to 1. It doesn't matter. They're not going to be used. Anything else? Oh, that looks like it. No. Draw groups unknown override specifier. Oh. Didn't include that. Oh. Okay, one last one. Cannot convert from uint. I'm not sure what that is. Is our buffer actually? Yeah, buffer takes in count. Oh wait. Vertex buffer cannot. Oh, that's a vertex buffer. I forgot. We also need a new constructor for this one. Because vertex array just contains a vertex buffer, and the vertex buffer contains the actual data. So we need a constructor for this one that takes no data as well. And I think that's all we have to do, actually. We just won't write to it. We have nothing to write, but I'll still. Okay, hopefully now it'll all compile. Finally, there we go. And we have our, the only thing left to do now is actually define the distinction between dynamics and sprite groups, how they're drawn. So if I run this now, I think we'll probably get nothing. But Uh-oh. Something's weird there. Probably just with the way stuff is being deleted. But what we need to do is we've set up our renderer so that it can, it has two different shaders, one for static and one for dynamic. So we actually need to create one of those shaders, a new shader. It'll be in our resources folder. I'll do add new. I'll call this one shader dynamic. And for now, I'll just take all of our texture stuff and copy it into here. And just like we'll edit shader dynamic in a minute. But for now, get rid of all this stuff. We don't need to draw our stuff independently anymore. We will still do. Actually, we'll keep that set val, but we'll do dl.draw on renderer. I should have called this dl, not just list. I mean, I guess dl isn't much more descriptive than list, but it's somewhat better. And then one last thing we need to change. That's what that memory error was, which could be very difficult to debug. I'll just show that again, just so you can see what it was. So everything. Oh wow, it's not even working now. It's probably because I did that. Everything works like fine, but then when you close it, it opens into this X memory file. With I mean, like just like what is all this? Just like voodoo nonsense, part of the standard library. This is a library file, X memory. Void deallocate. So this is something. This is like some function that's called as part of the delete operator, I think. And it says something. I don't even know. Like I don't even know what the error is. It doesn't really give you an error. But what's happening here is in our where is that? I think that's in dynamic list.cpp. Yeah, here we go. So we go through our list and we delete all of the contained dynamics. Remember, delete only works on stuff that's dynamically allocated. So this sort of just assumes that all of our dynamics are dynamically allocated, which, of course, when we finish setting this up, it will all be set up so that they are. But right now, these are allocated on the stack. So what's happening is when the end of scope is reached here, this dynamic list's destructor is called, and it calls delete on these things that are stack allocated, which is just an error. So we need to go ahead and put these on the heap with new dynamic. And then now if we run, oh, well, these are pointers, of course. Now if we run and then close, everything will be just fine. And let's go ahead and draw as well. So there seems to be something else wrong though with our draw. It seems to just be drawing something that doesn't exist. So I probably just missed a like null pointer check somewhere along the line. Let's see where that might be. So we call dynamic list draw, which comes in here. Okay, so we're definitely checking this. And then in draw group.draw, yeah, we're checking if that exists. Let's just try printing some stuff out. See where we crash here. I'm guessing it's in one of these two methods. Oh, no, it's not. We actually got through both of them. Okay. I wonder where it is then. I don't think I'm going to spend too much more time on this, because I'm not sure what's going on, but I'm sure I just mistyped something dumb. But this should be working, which is very unsatisfying of me to say, but it should be working. And I'm already running long, so let's just power through this and I'll have it fixed by next time. I'll have it fixed in like the code that I push to GitHub, so when you're done watching this video, you can just go check there and see what's different. Okay, so this should be working. It's not, but even if it were working, it would be the exact same result as we had before. Like we have this whole like complicated mess of a system. It's not really a mess, but it's complicated for sure. And it doesn't do anything. Like nothing changed. It still just draws everything the same way it was. And the reason for that is we haven't actually changed the order in which things are drawn. Now, I say the order in which things are drawn. We don't want to change that. Remember, that's the whole point of batching all these things together, is that the order doesn't matter. What does matter is something called the depth buffer. So this is like an additional thing that you can enable on your frame buffer, your OpenGL frame buffer. So right here in our core file here, we can do gl enable gl depth test. What depth test does is it sort of adds another layer to your frame buffer. By default, it just stores color data, but this adds another layer of floating point values. So each pixel has its own floating point value. They're normalized between 0 and 1. And that specifies the depth. So each frame, there will be each frame we will clear the depth buffer, so initialize it to all 0 or all 1, and then for each pixel that's drawn, it'll check if its depth value is less than the depth value that's already in the frame buffer, then it will draw. Otherwise, it won't draw. And this is how we can sort of dynamically select which pixels actually end up in the frame buffer, regardless of the order they're drawn in. So there is a bit more to this that I'm not going to touch on. If I go to docs.gl here, we have gl depth func. So this is, and a better resource actually is probably like this page, because I don't know, either one. I guess this one has the same thing, but it basically specifies how the depth buffer is used, like what the actual operation performed to determine whether or not a pixel should be drawn based on its depth compared to the depth buffer's value. That depends on this function here. By default, the function is GL-less, and I'm not going to change that. We have no reason to change that, so I'm just not even going to touch on it. But just so you know, there is like something else happening here, and you could set this with GL depth func. Just like GL blend func up there, but we're not going to be doing that. Okay, so that's our core file. In our renderer now, in clear, we now have like another layer to our frame buffer. So we're going to clear GL color buffer bit or GL depth buffer bit. And these are flags. You can see this value is probably 4000, OX 4000, and this is OX 100. So these, you are meant to do stuff like this where you perform binary operations. It just like creates a single flag variable that it's passed into here, and I don't know, it's bitwise stuff. Okay, so we're clearing the depth buffer every frame, which is good. But now we need to come into our shaders and actually set some of these depth values. So we'll start just with our dynamic shader here. We'll have another float called iCenterY. And then we will have another output variable called vDepth. So this vDepth, it has to be valued between 0 and 1. And it is going to depend on for us, for like my implementation of this, it's the depth of any pixel is going to depend on that pixel's Y value on the screen. So going back to that example I showed earlier, you can see here that in this case, my character, the one I'm actually moving around, is drawn behind here, but behind this other character, because he is higher up on the screen. He has a higher Y value, a high center Y value than this character. Center Y meaning the center point of this actual dynamic. But then when I pass through here, when my Y value, my center Y value becomes greater, I'm drawn on top. So that's how we're going to determine the draw order. And you could change this to do center X, or you could take in the whole position vector if you wanted, but I'm just doing center Y. So we're going to take our center Y, add it to our camera.y, multiply by our scale.y, add 1 and divide by 2 to normalize it into the 0, 1 range, because this by default will be in the -1 to 1 range. And then we're going to have to clamp it to some special values here. I'll define those up here. So these values, I think, like, I don't know, I'll have to explain this as we do our static stuff as well, but basically these just, we clamp these values to reserve space for our static geometry, because we want some of our static geometry to be drawn in the background. So that's going to have like a certain depth value that we don't want our dynamics to be able to have, because we want the dynamics to always be drawn on top of the background, at least. And then we also want some of our static data to be drawn in the foreground. And so that's going to have another separate like maximum value. So we clamp our dynamics into this sort of fake range just to make sure they are never colliding with the foreground or background. So that's our vertex shader there. Then in our fragment, we will take in our vDepth variable. And all we have to do here is output to another variable, gl_frag_depth, just like that. And that's it. So now, obviously, we've added this new thing, so we need to change our dynamics actual vertex data to add a new field here. And the first thing I'll do is come into core.h. This is why we've defined all these constants. We now have floats per dynamic vertex equal to 6, and that's all we need to change. So we have our I there. This I should be floats per dynamic vertex as well. And then we need our center Y. And this will just be the Y position of our position vector, because that, based on the way we're writing this other data in, this is the center of our dynamic. Okay. Now we need to alter the description here from 221 to 2221 to match this layout we have of vec2, vec2, float, float, 2211. And when we run, we should see the correct draw order for our dynamics. So we have these two, this dynamic, like player movable one here, and then just the box there. So we should see the player being drawn underneath the box when it's higher up on the screen, and in front of the box when it's lower down on the screen. And I think this will probably still be broken again because I messed something up somewhere. Yeah, so that's unfortunate, but again, I'll fix that before I push to GitHub. So unfortunately, we can't see this, but our our system for handling static map data is weird. And the reason for this is that in our static map data is still being drawn with shader texture, which doesn't set GL frag depth anywhere. So it has a default value of 0. It's sort of intuitive. But as I was saying, our default depth function, if I still have that pulled up, is GL less, which says passes if the incoming depth value is less than the stored depth value. Now, the incoming depth value will always be between 0 and 1, and our frame buffer is initialized to store 0. So nothing in the range 0 to 1 is less than 0, so it's never going to get drawn. So we will also have to define some constants in our shader texture class here. As well as take in the actual depth. And this depth is just going to be a hard-coded value, depending on whether or not it's in the foreground or the background. And we will just pass that out to vdepth. Take in vdepth here. And then, of course, write that out to GL frag depth. Okay, so as I was saying, this depth value will never change. It's not like dynamic where it's based on our position. It's just going to be this is foreground or this is background, done. So we'll come back to our core file here and set our floats per vertex now is also 6. And then in our sprite group, we will actually set this value. Now we could just like say everything is in the background for now. Everything is just 1. But we already have actually this in our tile structure here. We have a layer. And we can use this layer to divide this layer like index to divide our map up into multiple different layers of geometry. So what I've been talking about is just the case where you have very simple foreground and background. And I think that's all you'd really need. Like, I don't know, I can't think of a case where you'd want like a mid-ground thing. Like we don't have parallax, so that wouldn't really make sense, I don't think. But either way, I don't like hard coding values. So I'll define a uint here called sLayerCount. And then we can use this in our thing here. Instead of just hard coding it into the background, we will use the current tiles layer property, the current tiles layer value to determine its like depth float value. And we can do that with this simple equation where if tile.layer is 1, this would be 1 minus 1 times 1 over 1, so 0, meaning that obviously nothing is less than 0, so it's in the foreground because nothing can be drawn on top of it. And if tile.layer is 0, this would be 1 minus 1 times 0 over 1. So that'll be a resulting value of 1, which is in the background because everything in the range between 0 and 1 is less than 1, so everything will be drawn on top of it. And we'll also now need a, like, just in case, just so the user doesn't make any errors and like doesn't get any feedback on them. We'll have another tool here called checkLayer, which we'll just use when creating our tiles. So if the given layer is greater than or equal to sprite group .slayer_count, then it's an invalid layer. So we're only supporting layers 0 and 1. So if they put in 2, this will yell at them and let them know they messed up. Okay, and then we will use this in our add tile function here. And our add rect function as well. Okay, so that's all we need. Unfortunately, this is an underwhelming conclusion to a very long and arduous episode, just because nothing actually works right now. But it should be working. So again, I'll have the correct version of the code posted to GitHub. So, and I'll probably put in the comments like what I messed up, so you can change it yourself, just so you don't have to scour for it. And then when you run it, you should get some pretty cool things where your dynamics, no matter how you have, how many you have, you can like sort of generate them in a loop. And I'll probably include a simple loop in the code I push to GitHub just so you can see it. You can have a bunch of dynamics and they'll all be like ordered correctly depending on their Y value on the screen. And also they'll interact correctly with the map data, so you can mess around with your map file here and set the layer to either 0 or 1 and see how that affects the draw order. So yeah, this is like the end of our dynamic system. And next time we'll be starting on hitboxes. Sorry that it turned out it didn't actually show anything, but I don't know, it's probably boring for you to watch me just like debug for 10 minutes, so I'm not going to include that. But yeah, next time we'll be starting on hitboxes, which is a bigger system even than dynamics. I think it's going to take at least 3 episodes. I certainly won't try to cram it into 2 episodes like this. I can see now that this is almost 2 hours long. Oh God, sorry. But yeah, I'll stop rambling. I'll see you next time.